Hello everyone, let's solve this interesting question for today. If anyone is interested to solve this question, please pause the video and solve the question and comment on the answer. I'm going to start the solution in. There is some more additional information required to solve this question. The additional information is the two green rectangles in the diagram are congruent. You know what the congruent means, right? If two shapes are congruent, then their corresponding sides and corresponding angles are also equal. Now, let's dive into the solution. Let's name the common point of both these triangles and the diameter intersection as O. Till now, the point O is not the center of the semicircle. It is just the intersection point of both the rectangles and the diameter of the semicircle. Let's name some more points on this diagram. Here it is A, here it is B, and here it is C. Let's join the points from O to A and B. So, draw lines from O to A and O to B. OA and OB are not the radius of the semicircle. Don't misunderstand that, because nowhere it is proven or given that O is the center of the semicircle. Now draw one more line from A to B. The line AB is the chord for the semicircle, right? So I am mentioning it here. AB is chord. Now can I say OA is equals to OB? You can ask, when they are not the radius, how they both are equal? They both are equal because those two rectangles are congruent. In congruent figures, the corresponding sides, angles and their diagonals are also equal. So OA is equal to OB because of congruent rectangles. Now triangle OAB is the isosceles triangle, right? It is isosceles triangle because both the sides OA and OB are equal. Let's draw an altitude from O to AB. Now you have to remember one of the important properties of isosceles triangles. In isosceles triangles, the altitudes divide the base into two equal parts. So if we name the intersection point as D, then AD and BD are equal. Now, how many of you know perpendicular chord theorem? What perpendicular chord theorem is saying is, when a perpendicular is drawn from center of the circle to any of its chords, the altitude bisects the chord into two equal parts. So, if we try to fit the perpendicular chord theorem here, OD is altitude, AB is chord. Main important thing is AD is equals to DB. For all these things to happen, O should be the center of the semicircle. So now what we proved is O is the center of the semicircle. Let's dive into the original solution now. Now I just removed the chord of the semicircle which we draw previously. Now let's name some more points. Let's name this point as D and this vertices as D dash. Now I am trying to bring two congruent triangles. Let's consider the triangle ADO and triangle OD dash and B. Let's draw this diagram separately also. At the corners we have 90 degrees, right? Because these pieces are extracted from your rectangles. As the two rectangles are congruent, they have equal lengths and equal widths. So these two lengths are equal and these two widths are also equal. And we have one angle is 90 degrees. From side angle side congruency, these two triangles are congruent. If two figures are said to be congruent, then their corresponding sides and angles, everything is equal. So if I am treating this angle as alpha, this will become 90 minus alpha, right? As sum of angles on a triangle is 180 degrees. So this one become alpha and this one becomes 90 minus alpha because of the congruency. If you observe properly, we can write angle AOB as sum of two parts, right? Sum of AOD angle plus angle D dash OB. From our congruent triangles, we can write AOD as 90 minus alpha plus D dash OB as alpha. So angle AOB is equals to 90 degrees. So the angle AOB, I am marking it as 90 degrees. Now in the diagram we are having semicircle, right? Why can't we construct the full circle based on this semicircle? Let's complete this circle. So now this is the full circle. Let's mark a point on the bottom side of the semicircle as E. Now draw lines from A to E and B to E. Now quadrilateral ACBE is a cyclic one, right? We all know sum of opposite angles in a cyclic quadrilateral is equals to 180 degrees. So angle at C plus angle at E is equals to 180 degrees. Let's keep this aside because we have to use it later. From one of the Euclid's angle theorem, we can say the angle obtained at the circumference of the circle is alpha, then the angle obtained at the center is 2 alpha. If anyone is having doubt how this theorem is derived, I already made a specific video for this concept. I will leave that video in the iCard. If anyone is interested, go and check the video. Let's come back to this question. As we know, 2 alpha is equals to 90 degrees, alpha is equals to 45 degrees. So, the angle at E is equals to 45 degrees. If I substitute that 45 degrees in this equation, I will get angle C, right? So, angle C plus angle E is equals to 180 degrees. Angle C plus 45 degrees is equals to 180 degrees. So, angle C is equals to 180 degrees minus 45 degrees. Angle C is equals to 100 and angle C is the one which we have to find. As a recap of this question, what are the things we find? We found O is the center of the semicircle and we take two congruent triangles. We proved the angle at O is 90 degrees. After that, we discussed about the Euclid's angle theorem, property of the cyclic quadrilaterals, which is sum of opposite angles is 180 degrees. From all these findings, we find angle C is equal to 135 degrees. If you like this video and explanation, please like the video and subscribe to the channel.